Well, hello, most wonderful chemistry students, my best chemistry students, AP and IB chemistry at Allen High School. And you IB students, I know there are probably times when you are wondering why I don't always say IB, and it's not that I don't remember you, but honestly, this is much more of an AP issue than it is the IB. You'll see it when you take the AP test, but on your IB test next year, you won't be seeing quite as much, certainly not as significant of an emphasis. So let's take a look at the next of our example of our single replacement reactions. Now, this time what we're looking at is an active metal, and again, don't have to worry about defining that yet, but there's a series of these that react with water. So I'm going to ask you to give me a reminder in class next time, because you know what your old biddy's like. I can't even remember where I leave my coffee cup, much less this. There are 2 videos that I want to show you on these types of reactions. So remind me to bring those up and show those to you. Now, in this case, the example that we have is cesium. So you see the word piece of cesium, and I hope that makes you realize this is cesium with an oxidation state of 0. So no charge, huncocesium, hasn't given any electrons to anything yet, so it's hanging on to all of its electrons. Now, I know this seems a little bit odd, but when I react with water, I like to write my water as HOH. Now, remember, we talked about that. Never, ever, ever dissociate water in these types of reactions, but it's okay if we think of it as the H plus and the OH minus. Just don't write it that way. Now, cesium is a metal, and again, metals are losers. It's a group 1 metal, so it's going to lose 1 electron to become cesium plus 1. That means it's going to dance with, quote unquote, the negative OH of water. Again, we don't write it that way. So I'd get cesium hydroxide. Now, who gets kicked to the curb then in this case, but poor old hydrogen? And one thing we need to remember, and that was why we had at the beginning of the videos, is that hydrogen's never really alone because it's diatomic. So don't forget that it's diatomic. Don't forget that one of the reactants, in this case, will almost always go to an oxidation state of 0. There's a few exceptions where you might go from a lower oxidation number to a higher oxidation number or vice versa. But more often than not, these are 0. Now, we've got to remember your old biddy, BD cubed. And we got to balance this baby. So we've got 3 hydrogens, 2 hydrogens there, so I'm going to put a 2 there. That balances my hydrogens there. Okay, I had an even odd issue. When you have an even odd, multiply by 2. So that means I need 2 cesiums. Now we have to dissociate. This is a pure metal. We're certainly not going to dissociate this. Remember, we do not dissociate water. But group 1 hydroxides are all strong bases. So we are going to dissociate that. And don't forget that you not only get 2 cesiums, but you also get 2 hydroxides. Now let's evaluate what's happened here. The cesium went from 0, remember we just discussed that, to plus 1. That's less negative, so it lost electrons, which we call oxidation. The hydrogen in water went from plus 1, so in water we would have HOH, and the oxidation states of these are oxygens minus 1, and each hydrogen is plus 1 oxidation state. Oxygen's almost always minus 2. You saw peroxide in this last unit, and that was the one that was minus 1. And so the hydrogen went from plus 1 to 0, which made it more negative, which means it gained electrons, which we call reduction. Now, let's take a look at some interesting questions that might be asked. Some of the things that I could envision them asking, the AP readers, is what's evidence of a chemical reaction? That's a critical piece of labs. Well, hydrogen's a gas. We would see gas bubbles. Now, another thing that's important is for you to know the results of a splint test. And so, reminder 2. We're going to react. So reminder 1 was the videos. Reminder 2 is to ask me to do the zinc HCl demo so that we can see what happens when hydrogen reacts with oxygen. In a splint test, it's going to pop. It actually sounds like it's barking like a little chihuahua. So we're going to do that splint test. And then another thing I could envision, this really dredges back in your memory here, but it could ask what the pH is, or it could ask you if it was greater than 7 or less than 7. Since we have a base, we would predict a pH greater than 7. Now I know we haven't talked about acids and bases, but I think that much should be familiar to you. Now let's go on to the next one. This is the demo I want to do for you. It's lots of fun, and Mr. Coder taught me how to do it well this time. Followed his instructions exactly, and it worked very, very well. We're going to use HCl instead of HBr, but we've got zinc plus HCl. Now, HCl really breaks apart into H plus and Cl minus. We're going to see that in a minute. I'm just getting at the prediction state. Zinc is a metal. Remember, metals are losers. So when zinc goes into a reaction, the only oxidation state it can take is zinc plus 2. And so we're going to get zinc chloride. And remember, this is all work that you don't want to show on your answer box. That would free up the H pluses to become hydrogen gas. Now remember your old biddy. We have to balance. So I've got 2 H's here, so I need a 2 there. That gives me my 2 chlorides as well. That should be it. All right. Zinc's a solid metal with an oxidation number of 0. Don't do anything with that. Strong acids, we dissociate. 2H plus, 2Cl minus. Zinc chloride. You just had your solubility quiz, and it's for this reason that you see it. I'd get zinc 2 plus 2Cl minus plus that hydrogen gas present. And now, if you hadn't seen it earlier, it emerges that chloride would be our spectator ion. So what you want to write as your final answer in your box is zinc plus 2H plus yields zinc 2 plus hydrogen gas. So that's the active metal plus an acid. Now let's do the halogen example. In the halogen example, we have liquid bromine. So that would be Br. Remember, bromine is one of your diatomics. Halogens are diatomics. They're all diatomics. Plus lithium is group 1, iodide's -1, so there's lithium iodide. And I'm going to get lithium bromide. This time we have a nonmetal. Bromine wants to become bromide, which is negative. That means it wants to dance with that positive lithium. So we'd have lithium bromide. That leaves iodine all by iodide to become iodine, which we know is diatomic, so it's never really all by itself. So I need a 2 here and a 2 here. Now this said solution of, and this is soluble, so we'd say aqueous. And I hope you can see right away that we could get rid of that. And we've already seen examples where in the example, and they give you a chemical reaction, they seem to just throw out those group 1 metals willy-nilly. And we can if it's an aqueous system. So now we do have to rewrite it. Bromine, oxidation state 0, plus 2 iodides go to 2 bromides plus I2. So bromine went to bromide, which is more negative, so it was reduced. Iodide went from -1 to 0, and so it was oxidized. And I hope we're kind of getting the hang of this. We won't see the tough redox for quite a while. Now, there's one more example that's kind of an odd example. I haven't come across it very much, but I wanted to share it with you, and I didn't want to give you exactly the one I gave you in your homework, so I made one up. And in this case, we're going to assume that it proceeds as written. I'm not actually positive that it does, but we're going to make that assumption right now. Hydrogen gas is passed over hot copper 2 oxide. Do you notice that there's no water here? This is not an aqueous solution. No water. Nothing can dissociate. Even if it would be quote unquote soluble, you can't dissociate it if there's no water present. Now, we have a choice here. H can take the place of the copper to make H2O. In theory, hydrogen could replace oxygen. We do have a class of compounds called hydrides, where the hydrogen is -1 with a metal. But, you know, if oxygen's around and hydrogen's around, and one of them's got to decide who gets the electrons, oxygen's winning that battle. So that means that the hydrogen's going to replace the copper. And so we'd get water and then solid copper all by itself. Nothing to dissociate, nothing to separate, but we do need to double check our balancing, and I'm looking and it is balanced as is. So that's actually much shorter than I thought, which will make you very happy, those of you who are watching it after the homecoming weekend. And so I look forward to seeing you in class when we will work on that homework I handed out weeks and weeks and weeks ago. See you then.